Hello everyone, welcome to this video minimum bit flip to convert numbers. So in this program we receive as input two integer. That means for instance you are going to receive 10 and 7, and you are supposed to return the number of operation or the number of flip you need to apply to convert the first number to the second number. Pay attention that the conversion is performed to the binary representation of each numbers. That means, let's say I have this, for instance, 10, the binary representation of 10 is actually this, and the binary representation of 7 is this. Now, if I want to move from this to this, I need to flip the first one into a 0 because we are starting here with 0. I need to flip this into a 1. I need to flip this. I don't need to flip this actually, so I just perform already two operations, and then I need to flip also the 0 into a 1, and by doing so I will be able to flip this into this. That is actually the conversion. So for me to solve this, I will come up with two approaches. The first approach is what I will call like the methodic approach, which is kind of the implementation of what has been stated here. And after that, I'm going to implement another approach, which is two-line. Really interesting, that can be used in context, but it's not that methodic, I would say, but it's nice to know. So let us start with the first approach. The first approach will be exactly the implementation of what we have here. We have a start and an end, which is 10 power of 9 less than 10 power of 9. So if I take 32-bit, it will be enough because this number is actually less than the value of 2 power of 32. So for that, I can allow myself to take a 32-bit. So I'm going to say, I'm going to use bit set of 32. I will call them like this. I have the start and then I have the goal. So S and G are actually binary representation code on 32-bit of the start and the end. So this is what I did, and then after that, now I need to convert them into string. I'll just call it double S of S dot string dot to string. You may see where I'm going. Sorry. So what is happening here is that I'm converting. What is happening here? I need to parenthesis a function. What is happening here is that I'm converting first my integer into a binary representation coded on 32-bit, and after that I'm converting that 32-bit into a string. Now that I have the string, I have something like this where I can loop and compare the differences. So what I can do here now, I can loop from the start to the end, and whenever the bits are actually different, I know I need to perform a flip, so I increment a certain counter. So what will it look like? So I'll have something like a counter here. I'll have it in result, and what I will do is that I will say for I will just check. I can do it if I can directly use something like this. And I return result here. So what does it mean? This is saying that I'm going to loop from the first to the last bit, to the last digit, and I will say if they are different, this will return true, and then true is actually this true is going to be converted into 1. That's how it works when you are doing with binary, when you're doing with int and boolean. So if it's true, this result is going to be incremented by 1, so this one need to initialize as 0, and if it's false, this is going to be converted into 0, so nothing will increment. So this is one way of solving this. Let us run and see what it gives. So it's working. Let us submit. So we have everything green, performing pretty well. Nice. Now let me share with you the second approach I was talking about. The second approach is basically a different way of approaching the thing. So what we have here is that we are converting all of the two numbers and we are looping. What we can do is that we can find the XOR operator of the start and the goal. The XOR operator is actually the operator that return 0, that return 1 only if bits are different. That means if you make 1 XOR 1, it's going to give you 0, 0 XOR 0 is going to give you 0, 1 XOR 0 is going to give you 1. So it return 1 only if the bits are different. So if I apply the XOR operator like this of this guy, so I will call it maybe output, this guy contain the number of 1 containing in this one represent the number of differences that we have into the start and the goal. Does that make sense? Okay, so now that we have this, we know that we just need to count the number of 1 here, and then we have let's say we have a function for that in the bitwise, in the bit set, which is .count. So we can do something like this. The number of 1 of output is the number of differences that we have between the start and the goal, and the count is counting the number of 1 we have in a bit set. So let us run this. Working. Let us submit. Also working. So this was my two approaches of solving this. We have the first one, which is like really methodic. You are applying something that has been described into the problem statement, and the other one, which is also interesting for me because it can help in context. I hope you did enjoy it. Don't forget to like, share, and subscribe. See you tomorrow for a new video. Ciao.